Has the mystery surrounding Oumuamua finally been solved since its discovery 7 years ago? The interstellar visitor has been overshadowed by one central question. What on earth is it? Because while the mysterious flying object is sometimes thought to be a comet and sometimes an asteroid, it also confuses experts with the fact that it miraculously accelerates after flying past the sun. In view of this inexplicable burst of speed, there's even speculation that Oumuamua is, in fact, an alien spacecraft, and that's not us saying it, but renowned Harvard professor A.V.I. Loeb. Now, astronomers believe they have identified the real reason for Oumuamua's unexpected acceleration, and it doesn't really have much to do with extraterrestrial civilizations and exotic research probes. On October 19, 2017, modern space exploration reached a significant milestone. This was a day that Robert Werik first managed to identify an object in the solar system that was clearly of interstellar origin. Despite all this, the initial euphoria quickly gave way to great confusion. The properties of the object were so strange and unusual that no researcher knew what we were dealing with here. Christened Oumuamua, which means leader or scout, the interstellar visitor was initially thought by experts to be a comet. However, this assessment was soon discarded after follow-up observations did not reveal any tail or coma typical of a comet. And so it came to pass that only a week after the discovery, the astronomical turnaround occurred, and Oumuamua was henceforth considered an asteroid. So, was the case solved? Well, not really, because the object did, in fact, display flight behavior that defied all known asteroid patterns. But one thing at a time. When Oumuamua was discovered on October 19th, it was already on its way back into interstellar space. Scientists calculated that it had already passed its closest point to the Sun, known as perihelion, on September 9th. And while the object had come as close as 37.6 million kilometers to our mother star in the course of this, it then did something that left the scientists completely baffled. In detail, the orbit analysis revealed a mysterious acceleration. In other words, when Oumuamua moved away from the Sun again, it traveled a little faster than the mere influence of gravity would have allowed. From that point on, the experts were inevitably confronted with the question of what was behind this unexpected speed boost. Initially, outgassing of volatile components were proposed as a possible explanation. This is not surprising, since such a process is anything but unusual, and it occurs, among other things, when a body is heated to high temperatures. And yet, this assumption also had a small but crucial catch, because usually outgassing is accompanied by a significant change in rotational behavior, and this simply could not be detected in the case of Oumuamua. The mystery deepens. In order to shed light on the true origins of Oumuamua, experts subsequently directed practically all the telescopes at their disposal to the interstellar visitor. In the course of this, they also realized that the object is subject to exceptionally strong fluctuations in brightness, which in turn indicates that it resembles an oversized cigar in shape. At the same time, however, the collected data was insufficient to reconcile the aforementioned brightness fluctuations with a suitable rotational behavior. In view of this, it appears that Oumuamua does not rotate around one of its main axes but literally lurches through space. No less confusing was the fact that no dust was detected in the immediate vicinity of the object. As a result, scientists assume that it does not contain water and may consist entirely of metal. With regard to the exact dimensions, the experts again had to rely on estimates due to the lack of tangible data. Depending on the values used for reflectivity, density, internal tensile strength, and axis of rotation, different dimensions result. So, it is conceivable that Oumuamua is either 800 or just 100 meters long. And when it comes to the object's origin, scientists have yet to provide a clear answer. The vague approach merely suggests that the direction of origin is somewhere in the constellation Lyra. Shortly after its classification as an asteroid, Oumuamua was then reclassified as a comet, but not every researcher is convinced by this classification. Other studies have concluded that the object is more likely to consist of frozen hydrogen, or perhaps Oumuamua is a nitrogen ice fragment that was once blasted out of a Pluto-like exoplanet. So far, so conservative, but it could be a lot more controversial. Harvard professor A.V.I. Loeb actually approached the Oumuamua mystery from a slightly different direction and suggested that we might not be dealing with a natural object at all but with an artificially created one. Is Oumuamua an alien spacecraft? A.V.I. Loeb is not exactly what you would call an uncontroversial astrophysicist. For example, he claimed to have found mysterious objects at the bottom of the Pacific Ocean that would indicate, and I quote, extraterrestrial technology. More specifically, this refers to hundreds of tiny spheres of interstellar origin that Loeb claims to have detected in the remains of a meteorite. And you probably also remember the alleged alien mummies, which were presented in the Mexican Parliament in September 2023. And guess who was live-streamed from Harvard to report on the search for extraterrestrial objects in the atmosphere and in the solar system? With this in mind, Loeb's comments on Oumuamua are not really surprising either. It could actually be an artificially created object from an extraterrestrial civilization. The observed acceleration and the lack of dust formation would perfectly match the properties that would be expected of an extremely thin object with a large surface area. On this basis, Loeb speculated that Oumuamua could, in fact, be a solar sail, a body propelled by the radiation pressure of the sun or another star. But if you now think that the rest of the research community immediately dismissed Loeb's remarks as absolute nonsense, you're wrong. In fact, the possibility of an artificial origin was at least not ruled out. And so it happened that the radio telescope at the Green Bank Observatory in West Virginia turned its gaze to Oumuamua to search for potential signals of artificial origin. A few weeks later, however, the alien enthusiasts received sobering news. No evidence of artificial signals could be found. The real reason for the acceleration? Where technical drive became increasingly unlikely as a cause of acceleration, the experts had to look for other, more natural explanations. And although Oumuamua was discovered in October 2017, as mentioned, it was not until March 2023 that the relieving news finally made the rounds, and astronomers announced that they had finally cracked the mystery surrounding our interstellar guest. And even if the corresponding explanation has nothing to do with solar sails and extraterrestrial civilizations, at least some alien hope remains for the more alternative camp, because these are purely theoretical models and considerations that offer a plausible solution but have not been directly proven in Oumuamua. Be that as it may, it is clear that no researcher has ever seen a comet that does not have a dust coma and is accelerating in such a strange way as Oumuamua. But it's also clear that Daryl Seligman and Jennifer Borgner have nevertheless managed to reconcile the strange circumstances with coherent theory. According to the experts, the answer to the Oumuamua question is hydrogen propulsion. In any case, the duo came to this conclusion after examining a series of laboratory experiments conducted between the 1970s and 1990s. These tests show that water ice can disintegrate into molecular hydrogen under the influence of intense cosmic radiation, and an object moving through the interstellar medium is literally cooked by that same radiation. In view of this, it seems reasonable to assume that Oumuamua also formed hydrogen. However, the fact that the hydrogen should not have escaped into space immediately, in order to explain the speed boost after Oumuamua's orbit around the Sun, poses a problem. Fortunately, Seligman and Borgner had a suitable solution for this, too. The hydrogen initially remained trapped in the pores of the ice. The theoretical calculations showed that this is anything but improbable. Most of the hydrogen formed in the ice under interstellar conditions remains trapped in the water matrix. This only changes when the icy prison warms up to temperatures between minus 258 and minus 133 degrees Celsius. But as long as this temperature limit is not exceeded, the water ice remains amorphous. It only crystallizes when it warms up to the appropriate temperature. And while Oumuamua was entering our home system, the theory goes, the sun's rays heated up its outer crust, causing the water ice to change its structure. The pores that were opened in the ice during this process allowed the highly volatile hydrogen gas to escape. This also explains why the outgassing appeared invisible to the terrestrial scientists. The molecular hydrogen could not be identified by spectroscopic investigations at all. From a purely visual point of view, it therefore appeared that the flying object had neither a characteristic tail nor a coma, in contrast to the conventional outgassing of comets. The escape of hydrogen would also not produce any significant dust formation, and even if the ice matrix should have contained dust, it was most likely not carried away by the outgassing. Now, all this sounds nice and good, but is a special form of outgassing also suitable for explaining Oumuamua's surprising speed boost? Well, yes, it does, provided that the object is relatively compact. In the case of a comet several kilometers in size, outgassing would probably have no significant influence on flight behavior. But if the cigar-shaped object is only 100 meters long and 20 meters thick, the process could have generated sufficient for us to set the observed acceleration in motion. And now, you can create enough for us to set your click on the subscribe button in motion. Become part of our community and never miss a new video from us again. See you soon.